Good. So it says a sequence of patterns is made of dots and lines of unit length. Some of these lines form squares. The first three diagrams in the sequence are shown below. So this is diagram one, this is diagram two, and then this is diagram three. All right. Now there is some pattern between each of these diagrams. Take a minute, look at the diagram, and tell me if you think could recognize anything that's the pattern, right? Now, when you're looking for a pattern between two diagrams, what you should be looking at is, well, what's the first diagram and then what's the second diagram and what's different between the first and the second diagram and then what's different between the second and the third diagram. Any observations yet?
Yes.
Mm.
Um, I see in the first one it has six, and I mean the second one compared to the first one it has two more, and in the third diagram compared to the second one it has two more again.
Well, there's a lot happening in the diagram, so I need you to explain to me
Yeah.
what do you mean by two more? Two more what?
Okay,
Dots or lines?
the dots that are around the diagram. Yeah.
Okay, so the difference between the first and the second one is two extra dots, is what you're saying.
Yeah.
Okay, that's true, right? So, like, guys, the first diagram you have one, so this is the first diagram here, right? The second diagram, well, this is the first diagram, and everything else is an addition to that one, right? And then in the third one, this is actually the second diagram here. Then everything else is an addition to what's in the second diagram, right? So the difference, let's see, is there a difference in the number of straight lines? Well, there is, right? So you have one, two, three, four, five, six, seven. You have seven more lines here. And then seven more lines here as well. Let me not use dots to draw it. That's very misleading. Sorry, that was a poor choice on my behalf. In the first diagram, so let's actually, I'm going to outline the first diagram, but the second one, right? So I mean, so this was the first one here. This part is the first diagram. All right. And what is added is actually this part here, which is one, two, three, four, five, six, seven straight lines. And then one, two, three dots are added, right? And then in the third diagram, well, the third diagram is made up of the first, well, the second diagram, which is here. As you can see, we still have, you have that repeated one, two, three, four, five, six, seven lines added, and then three dots added. Oh, I forgot to outline these. So if you notice, guys, in each diagram, you have seven lines being added and three dots. So it means then that the fourth diagram, which we are required to draw, add more lines and dots to the diagram below to show diagram 4 of the sequence. So as you realize, each new diagram includes seven more straight lines and three dots. So this the fourth diagram, Zafi. Are you seeing that?
Yeah.
Right. So this fourth diagram here would include, so sorry, I want to draw the straight line first. So it will include four, five, six, seven straight lines and three new dots. One, two, three. Everybody saw that? Anybody is very confused about how I got the pattern? I'm gonna ask you individually. Ari, do you see how I got the new pattern? Does it make sense to you?
Mm-hmm.
Yeah? Okay.
Yeah.
Nia, what about you, Nia?
Yes, miss, this is totally easy.
Good. Oh, we have someone new joining us today. Sorry, love. I didn't even see when you came in. Hi, Kiana. How are you?
Hi, I'm good.
So we're looking at this investigation question, and I'm not sure at what point you came in, but did you see the whole thing so far?
Yeah, yeah, I understand.
Okay, beautiful. And the rest of you girls, just give me a thumbs up if you understand the pattern so far. Very good. If actually a better question is if you don't understand, send me a message or give me a thumbs down, right? Otherwise, I'm moving on. All right. So the first thing, guys, in the first part of most, or I should say all of the investigation questions, you have to complete a pattern, right? And like I said, how you identify the pattern, look for the difference with each new diagram. So in the first diagram, you had these 7 lines, and then you had 5 dots. And then in the second diagram, you had, well, what was in the first one, plus 7 new lines and 3 new dots. Then the third diagram had what was in the second diagram, that's in blue, plus the same 7 new lines and 3 new dots. So it is expected then for your fourth diagram to have what was in your third diagram plus 7 new lines and 3 dots. All right? And that's 2 marks, girls. Now, this is the part that students seem to falter with over here, right? The number of dots, D, and the number of unit lines that form each diagram, L, form a pattern, sorry. The values for D and L for the first 3 diagrams are written in the table below. Study the pattern of numbers in each row of the table and then complete the rows numbered 1, 2, and 3. So we kind of already figured out the number of dots that are being added and the number of lines, right? Because if you look at it, we already established that there are 1, 2, 3, 4, 5, 6, 7 new lines being added each time and 3 new dots. So you could see it from the diagram. Here, you need to represent it in this table. And even if you weren't sure in your diagram in the first part, then you can look at the numbers and you have to find the common difference or the constant increase between the numbers, right? So if you look at the number of dots, well, the common difference here is 3 because 5 plus 3 is 8, 8 plus 3 is 11. So what would I expect the number of dots to be in diagram 4? Anybody? What would I expect the number of dots to be in diagram 4?
14, miss.
14.
Yes, 14, right? Because it'll be 11 plus 3, which will give me 14, right? And then if we look at the number of lines, well, we already established from our diagram that it's the 7 lines that are being added, right? But if you weren't sure with your diagram, look at the numbers and see what is the constant increase here. Well, you would have to subtract, right? You'll say 15 take away 8 is 7, and 22 take away 7 is, sorry, 22 take away 15 is also 7. So it appears that you're adding 7 each time. 8 plus 7 is 15, 15 plus 7 is 22. So what would be the number of lines in that fourth diagram then?
29.
Correct. It'll be 29, right? Because you keep adding 7 lines. And then we could verify that in the diagram here, counting the lines and the dots, right? But we are correct here already. Now, Zafi, how are we going so far? That's the only reason I'm asking Zafi so much is because she is the one that outlined to me very boldly that she
Um,
had no clue what was going on.
um, I'm still trying to like process it. You could say back like the one for the lines. It's just the lines that is giving me trouble now.
Well, it
Giving
wouldn't
trouble.
be the lines in every situation. It could be anything. It could be dots. It doesn't have to be lines. The real question is, can you see that there's a difference between each, each 2 numbers here, like a common difference? Can you establish that?
Um,
Do you see how I got it? I said, well, what is the difference between 5 and 8? Tell me.
3.
3.
3.
So
Yeah.
5 plus 3 is 8. And then the difference
Mm-hmm.
between 8 and 11 is also 3. Plus
Mm-hmm.
3 is 11. And then the difference is, so then I expect the next difference to be 3 as well. So then 11 plus 3 is 14,
Mm-hmm.
right? Does that
Yeah.
make sense or no?
Yeah, that part made sense. And
Now with the line, it's the
times
exact same thing we're doing. What is the difference between 8 and 15?
7.
15 take away 8 is 7. So
Yeah.
8 plus
Yeah.
7 is 15. And then isn't that the same here between 15 and
Yeah.
22?
Yeah.
So that means that the common difference here or the constant increase is 7. So I would expect this third number, sorry, this number in diagram 4 to also be 7. So I'll say 22 plus 7 gives me 29.
Okay.
Yes
Yeah.
or no?
Yeah.
Miss,
Sure? Taffy? Sure, honey?
Yes, Miss, I'm very sure.
Okay, good. So Ari, raise a hand. Yes, Ari, talk to me.
I understand now.
Okay, so let me lower your hand. Okay, you lower it. Thank you. Right. So now, so that's 2 marks, right, girls? So that's the first thing that you need to do. You need to look just like how when we were doing the diagrams, we looked for the difference between the two diagrams, right? It's the same thing that you're gonna be doing in your table. You're gonna be looking for a difference between these sets of numbers. And you're looking downwards, right? So you're looking in each column. What is the constant increase from each diagram in terms of dots? Well, in each diagram, you add 3 new dots, and that's how you get the number of dots in a new diagram, right? And same thing I did for the lines. You look for that common increase, all right? Now, this part, we need to determine the diagram number that would have 59 dots in it, right? Now, there are some students who will just keep adding 3 until they get 59. Don't be a student like that, right? Unless you're really, really confused and you don't know what else to do, then I guess you could do that. But that will take up way too much time for a question that is worth merely 2 marks. All right. And this is question 7 in your paper. So you still have um, the long, long questions in section 2 to do. So I would suggest not to spend too much time on a 2 mark question. All right. However, once you have established the common difference, then you can actually figure out um, an equation to tell you the relationship between the diagram number and the number of dots. And how you do that? Well, first things first, we've already established that the number of dots is increasing by 3, right? So what we do is we take 3, all right? We're going to multiply that. If we let the diagram number represent, let's say, let's call it, no, sorry, we have D already. So let's call it N, right? So N, I'm gonna call it N, right? So you'll say 3 times N plus some number will give me the number of dots, right? And let me show you what that means literally with the numbers here, right? In other words, it means 3 times, now if the diagram number is n, here n is 1, n is 2, n is 3, and n is 4, right? Let's use one of the actual statements that well, one of the actual values that they gave us. So when n is 1, that means that 3 times 1 plus some number c is equal to the number of dots. So when n is 1, in the first diagram, the number of dots is 5. So that means 3 times n, which is 1 in this case, plus some value gives me number of dots 5, right? So in other words, well, 3 times 1 is 3, right? So 3 plus c is equal to 5. Daffy, if 3 plus c is equal to 5, what would c be equal to?
Repeat, I didn't hear you properly.
If 3 plus c is equal to 5, what would c be equal to?
2.
2, right? So that means that if c is equal to 2, it means that the general equation that you can use that links the diagram number to the number of dots is 3 times whatever the diagram number is. In this case, let's just call it n, plus 2 will give you the number of dots. And let's put that to the test. Well, when n is 2 in the second diagram, the number of dots is supposed to be 8. Let's see if that works out. Well, 3 times 2 plus 2 is actually equal to 8. So it does work out for that one. And just to be sure, let's see if it works out for when n is 3. We expect that the number of dots will be 11. So 3 times 3 plus 2 is actually 11. And therefore, we can establish that the equation that tells us the number of dots is 3 times n, where n is the diagram number, plus 2 gives us the number of dots in any diagram. So if we wanted to find out how many dots there are in the 10th diagram, we will say 3 times 10 plus 2, and that would give us the number of dots in the 10th diagram. So I have a question. What about if n was 6? If n was 6, what would be the number of dots in the diagram? Remember, this is the equation here. 3n plus c gives you the number of dots in the diagram. So if n is 6, guys, what would be the number of dots in the diagram?
Miss, would it be 20?
Yes, it would be. Tell us how. 20 is correct. Tell me how.
If n is 6, it'd be 3 times 6 is 18 plus 2 is 20.
That's right. All right. So Zafi, back to you. If n was 11, what would be the number of dots in the diagram?
35.
Correct. How you got it?
I did 3, open bracket 11, close bracket plus 2.
Yes. Correct. So that would be 30. How much? 35. All right. So that is how you establish the number of dots in the diagram. Right? Now, if you had to figure out the number of lines in the diagram, it's the same principle, right? You're going to use the common difference, right? Which for the number of lines is 7, and you're going to come up with an equation to link the relationship between the diagram with the number of lines. So, for example, so you see how the common difference for the number of dots was 3? So we came up with an equation 3 times n, the diagram number, plus some value c will give you the number of dots. That's exactly what we're going to do for the number of lines now. So the common difference for the number of lines is 7. So we'll say 7 times the diagram number n plus some value c is going to give me the number of lines in the diagram. And now we're going to substitute some of the values, right, from the actual table to figure out what C is in this case. So using the first one, when for the diagram number, when n is 1, we'll say 7 times 1 plus some value C is equal to 8, because in this first line here, n is equal to 1, that's the diagram number, and the number of lines is 8. So 7 times the diagram number 1 plus some value C gives me 8. What does that make C equal to then? 7 times 1 is 7, so 7 plus C is equal to 8. So if 7 plus C is equal to 8, girls, what is C?
1.
That's right, C is 1. And now let's put it to the test. Let's see if it works out for the rest of them. Well, when n is 2, 7 times 2 plus C, which is 1, well, that gives me 15. So it does work out for the second diagram. Let's see if it works out for the third diagram. 7 times 3, because if it's the third diagram, n will be 3. So 7 times 3 is 21 plus 1, which is 22. So we can establish then that this is the pattern. 7 times whatever the diagram number is, plus 1 will give you the number of lines. So 7 times the diagram number 1 is 7 plus 1 gives me 8, which is the number of lines. 7 times 2, when the diagram number is 2, plus 1 gives me 15, which is the number of lines in the diagram. Zafi, what about when the diagram number is 5? How many lines will I have?
37.
Oh, 36. 7 times 5 is 35.
Oh, my bad.
Yeah? So
Yeah.
you just made a mistake with the calculation, correct? Or did you add 2 instead of 1?
Oh, yeah, I think I did. Yeah,
Well,
I got
what about if the diagram number was 10? What would be the number of lines?
71.
Correct. 7 times 10 plus 1, which has given you 71, right? So now that we've established the relationship between the diagram number and the number of dots and the diagram number and the number of lines. So we've come up with the equation that gives us the number of lines and the number of dots given the diagram number. We could work it out to figure out what is the number of what is the diagram number when the number of dots is 59. So using the equation, right? The equation for the number of dots is 3n plus 2. So using that equation, basically they're telling us that 3n, let me use red for this one, 3n plus 2 gives me 59. So we need to work out what n is equal to when the number of dots is equal to 59. Or in other words, in which diagram will you have 59 dots? So you need to solve this equation, right? So if 3n plus 2 is 59, then 3n is equal to 59 minus 2. And that would mean that 3n is equal to 57, which makes n equal to what, 19? 3 into 5 is 1 remainder 2. 3 into 27 is 9. So yeah, so n is 19. So in the 19th diagram, number of dots that you will get is 59. And now we can also figure out what would be the number of lines that you would get because we know what diagram number is and we know what is the equation to get the number of lines. So you'll say 7 times n, which is 19, plus 1, which gives me 134. The investigation question, guys, in your exam tests your ability to see patterns and relationships, and it also tests your algebra, right? So I'm going to go through it one more time to show you how we came up with the equations and how we solved to figure out the number, the diagram number, for instance, or the number of lines. Going from the very beginning of the question, right? The first thing that you're asked to do in a question like this is you are asked to complete a sequence. So do the third diagram or the fourth diagram, what have you, in the sequence. So they'll show you a sequence. In this one, they showed you that you have a pattern with dots and lines, right? And what I told you just now is you have to see what is the difference between each pattern. So what is being added to it? What is being subtracted from it? What is happening? And we established that in each new diagram, like in diagram 2, and I'm literally doing it over because this is something that could be a bit confusing, right? So in each new diagram, for instance, in diagram 2, you have 1, 2, 3, 4, 5, 6 new lines, seven, sorry. 1, 2, 3, 4, 5, 6, 7 new lines being added and 4 dots. 1, 2, oh my gosh, 3 dots. Sorry. So the first diagram, you had 5 dots and you had 8 lines. Is it 8? Let me see. 1, 2, 3, 4, 5, 6, 7, 8. So you had 8 lines and 5 dots, right? In the second diagram, you had your first diagram plus 7 new lines and 3 new dots. In your third diagram, you had the same thing is being added, 3 new dots and 7 new lines. So that's the pattern there. It's in each new diagram, 7 new lines are being added and 3 new dots are being added. So the diagram that you would have to draw um, to complete diagram for the addition, you would have to make, because it says add more lines and dots to the diagram to show diagram 4 of the sequence, you're gonna have to do the same thing. You will add 7 lines and 3 dots. And that would be your new diagram for 2 marks. Now, exactly what we did here is what we have to do in the table, right? So we would have to fill in the total number of dots and the total number of lines in the fourth diagram. So you could have looked at your diagram, you could go back to your diagram and you could literally count the number of lines, right? Or you can just use the table given what we just discovered and work it out, because you know that in each new diagram you're adding 7 lines. But also, even just looking at these numbers, you could tell that the difference between the number of dots each time is 7, meaning that diagram 2 would be equal to 5 from diagram 1 plus 7. Sorry, for the dots is 3. Sorry. So 5 plus 3 gives you 8. And then 8 plus 3 gives you 11. So then in your 4 diagram, you would expect 11 plus 3 to give you 14. And with the lines, it was increasing by 7. So 8 plus 7 is 15. 15 plus 7 is 22. 22 plus 7 is 29. And that's how you got these values, right? Now, you are not now asked from part 2 and part 3. First, in part 3, most times it's better to solve well, you would actually have to, if you're using algebra, to solve part 3 before you could figure out part 2, right? Because part 3 gives you the generalization or the rule that is used to figure out the number of dots in each diagram and the number of lines in each diagram. How you go about figuring out the rule or the equation is step 1, you first find the common difference. So see, is there a difference between each of these numbers? We have already established that not only from this table, but from looking at the diagram. The common difference is 3 because each time you're adding 3 dots. So you come up with an equation. It's going to look something like whatever is the common difference, multiply by the diagram number plus a value C, right? So the equation that we came up with is D, which stands for the number of dots, is equal to 3n, which means 3 times the diagram number, plus some value C gives us the number of dots. And then you take your values from each of the rows to see if it works out, right? So first we did when n is 1. Well, when n is 1, it would mean 3 times 1 plus some value c gives me 5. And therefore, 3 plus c is equal to 5. So if 3 plus c is equal to 5, c would be equal to 5, take away 3, which is 2. So my assumption, right, because it's only an assumption at first until you test it with the other values. My assumption is that, or my calculation tells me that c would be 2. So now I put it to the test to see if I use this 3n plus 2 in each of these situations, I'll get the correct number of dots. So when n is 2, I'll say 3 times 2 plus 2, and it should give me 8. And that's correct because 3 times 2 is 6 and 6 plus 2 is 8. Then when n is 3, when the diagram number is 3, I'll say 3 times 3, which is 9, plus 2 gives me 11. So I've tested it out and it has worked for all three of them. So it's safe to say that the relationship between the diagram number and the number of dots is 3 times n, which is 3n plus 2 to give me the number of dots. Similarly, for the number of lines, I look at the common difference, which I've established is 7, and then I come up with an equation. It's going to be some linear equation. Most times you need to assume that it's a linear equation. Sometimes it could be a quadratic. Sometimes it could be like n squared or n squared plus 1 or something like that. But in this case, most times assume that it's a linear equation to begin with, right? So take the common difference and multiply that by the diagram number. So 7 times n plus, again, some value c will give me L, which is the number of lines. You take your values directly from the table, right? So when n is 1, when the diagram number is 1, 7 times 1 plus some value c will give me 8. So therefore, 7 plus c is equal to 8, since 7 times 1 is 7, right? And then c would be equal to 8, take away 7, which is 1. And now I'm going to put it to the test to see if this rule does hold true for the other situation. Well, when n is 2, I'm supposed to get the number of lines being 15. So we'll say 7 times 2 plus 1, which actually gives me 15. 7 times 2 is 14, and 14 plus 1 is 15. Then, when n is 3, I expect the number of lines to be 22. So 7 times 3 is 21, and 21 plus 1 is 22. So it works out. So therefore, I have established the rules for the number of lines and the number of dots. Now that I know what the rules are, I can figure out part 2 of the question, which gives me the number of dots, and I need to find the diagram number and the number of lines in that diagram. So I say, well, 3n, if the number of dots is 59, it means that 3n plus 2 is equal to 59. So solve for n in this case because n is the diagram number. So 3 times n plus 2 is 59. That means 3n is 59 minus 2, which means 3n is 57. And then 57 divided by 3 is 19. So the diagram that would have 59 dots is the 19th diagram. And once you know what the diagram number is, you could work out the number of lines by saying 7 times n plus 1. Well, if n is 19, it'll be 7. Oops, I forgot to change this. It'll be 7 times 19 plus 1, which gives me 134. All right? That's how you do it, guys. This is a strategy that you can use for the patterns question, the investigation question. All right, so now it says one of the diagrams in the sequence has 148 lines. Calculate the number of dots in the diagram. So if we're looking at number of lines, it means we're looking at this equation, right? Because this is the equation that gives us the number of lines. We don't know what n is, but if we were to find out what n is, we could figure out the number of dots because we could just substitute that value for n into the equation to calculate the number of dots. So first thing we do is calculate. So to calculate n, or to find n, we need to substitute this 148 into the equation, right? So to calculate n, we would say that 7n plus 1 is equal to 148 because that's the number of lines. And to get the number of lines, you use this equation 7n plus 1. So 7n is equal to 148 take away 1, which means that 7n is equal to 147. And therefore, n is 147 divided by 7, which makes n equal to 21, right? So now that we know that n is 21, we can calculate the number of dots. Because to calculate the number of dots, you use this equation, 3n plus 2. So to calculate the number of dots, the number of dots, when n is 21, we'll say 3 times n plus 2. So that'll be 3 times 21 plus 2, which is 65. So the number of dots in the diagram that has 148 lines will be 65. All right, I am going forward. Right, so if you're a more visual person, seeing the increase in hexagons will be easier for you, right? But if you can actually look at numbers, it might be easier to see the pattern here. So, like I said, look for the common difference, right? The common difference here, we already know that it is plus 2. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. So then the fifth diagram, what would it be, guys? How many hexagons will we have in the fifth diagram?
11.
11. 9 plus 2 is 11. What about the number of 6? I think we figured it out already. We said it was 8, right? I think it was 8. But if you're unsure, you could just check here. So see what's 23 take away 15. Well, 23 take away 15 is 8. And then 31 take 23 plus 8 is 31. And 31 plus 8 is 39. So the common difference here is plus 8. Right? So then I would expect the fifth one to have 39 plus 8, which is 47. All right. What about the parameter, guys? What's the difference, the common difference with the parameter?
4.
Yep, it's 4. 12 plus 4 is 16. 16 plus 4 is 20. 20 plus 4 is 24. 24 plus 4 is 28. All right. So the common difference with the number of hexagons is 2. You keep adding 2 each time. The number of sticks, the common difference is 8 because you keep adding 8 each time. And then with the parameter, the common difference is 4 because you keep adding 4 each time. And now to figure out what the general rule for the number of hexagons are, well, we already know the common difference is 2. So we create an equation with 2 times the diagram number, which is n, right? So that would be 2n plus some value c is equal to the number of hexagons, which is 8, right? So what we do now is we substitute a value of n, right? A value of h, and we see if it gives us, so we try to work out what c is, right? To try to establish the general rule. So if I'm using the diagram number as 1, that would be 2 times 1 plus c is equal to the number of hexagons, which is 3. So 2 plus c is equal to 3, which makes c equal to 3 take away 2, which is 1. And now we check to see if that rule holds true for each of the values of h. So it is expected based on my rule here, because my rule is that c is 1. So my rule tells me that 2 times n, the diagram number, plus 1 gives me the number of hexagons. So let's see. Well, when n is 2, 2 times 2 is 4, and 4 plus 1 is 5. So it holds true there. When n is 3, 2 times 3 is 6, plus 1 is 7. So it works there as well. When n is 4, 2 times 4 is 8, plus 1 is 9. So I can safely say that the rule to figure out the number of hexagons will be 2 times n plus 1. That gives me the number of hexagons. So if I know what n is, I could figure out the number of hexagons by substituting n into this equation, 2 times n plus 1, to figure out the number of hexagons. So Isabel, are you there?
Yes, Miss.
What about if the diagram number n, if it was 50, how many hexagons would I have? Isabel, do you know? Or do you need me to help you figure it out?
51.
50. If n was 50, what would be the number of hexagons?
Miss, give me 2 seconds.
Okay. You know what to do, honey, or do you need me to help you?
I'm a little confused.
Okay. So to figure out the number of hexagons, we have just established that the relationship between the diagram number and the number of hexagons, the rule that gives us the number of hexagons is 2n plus 1, where n is the diagram number. How I got that is because I first identified that the common difference between the number of hexagons is 2, right? Because 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11. So as you can see, the number of hexagons keep increasing by 2, right? From in each diagram, each new diagram has 2 more hexagons. So we assume that it's a linear relationship, meaning that you're going to get some kind of linear equation where it's 2, the common difference, multiplied by the diagram number, plus some value c, give us the number of hexagons. So we write that 2n plus c is equal to h. We're assuming that is the relationship. So we need to solve for c to really come up with that rule. So we take the values from one of the diagram number, the hexagons, to see if we could solve for c. So when n is 1, we substitute 1 into the equation, 2n plus c is equal to h. When n is 1, in the first diagram, the number of hexagons is 3. So 2 times 1 plus some value c will give me 3. Well, 2 times 1 is 2, and 2 plus c is equal to 3. So if 2 plus c is equal to 3, it means c is equal to 1. So you can use that rule, 2 times the diagram number plus 1 to give you the number of hexagons. When the diagram number is 2, 2 times 2 plus 1 gives me 5, which is the number of hexagons. When the diagram number is 3, 2 times 3 plus 1 will give me the number of hexagons in that diagram, which is 7. When the diagram number is 4, 2 times 4 plus 1 gives me the number of hexagons, which is 9. When the diagram number is 5, 2 times 5 plus 1 gives me 11. So my question is, if the diagram number was 50, how would we solve for the number of hexagons? What would you say? If n is 50.
It'll be 2 by 50 plus 1.
Correct. It'll be 2 times 50 plus 1, which is how much?
101.
101. What about if n was 30? How many hexagons will you have now?
61.
61, correct. How you got it?
Because you multiply 2 by 30 and you add 1.
Correct. You multiply 2 times the diagram number, and then you add 1. Um, Kaylin, what about if the diagram number was 35? How many hexagons will I have?
Okay, so okay, so first it would be 2 times 35 plus 1, and that's 71.
Correct. So you'll have 71 hexagons in the 35th diagram. Genesis, you there?
Yeah.
What about if the diagram number was 20? How many hexagons will I have?
41.
Correct. How you got it?
2 by 20 plus 1.
Correct. Let's see. Anna, what about if the diagram number was 10? How many hexagons would it have?
21.
Correct. How you got it?
10 by 2 plus 1.
That's right. Zafi, how you going there?
Yes, my brain is frying like fried chicken.
Let me ask you a question. What about if n was 8? What would be the number of hexagons?
Um, would it be 48?
Oh, what's the relationship?
Yeah,
How do you
no.
figure out the number of hexagons? N is 8.
Oh, right. Okay, so
Relationship is 2n plus
oh,
1, right?
yeah, yeah, yeah. Okay, but it take me a minute. It take me a minute. Okay, I'm gonna do it. 19.
2 times 8 is 16. 2
Oh,
times 8 is 16, and
oh,
16 plus 1 is 17.
oh,
So
but
if n was 8, then it'll be 2
no,
times
yeah,
8 plus 1.
it's 17.
Zafia, I think you need to learn your tables, huh?
Yeah, I do. I do. I need to relearn them.
All right. Okay. Well, I mean, the good thing is this paper has a calculator, so you could use your calculator. Sometimes under pressure, working out 2 times 8 is hard. right? Sometimes you could work out 2 times 8 and get a totally different number. In a math test, guys, I'm not even gonna lie to you. I work out, I will work out on a calculator 1 plus 1 because under exam conditions, I will doubt myself that 1 plus 1 is 2. So I do that on the calculator. So Zafi, use your calculator, right?
Yeah.
The long paper, you have your calculator, use it. Don't rely on memory when you have your calculator available to you. So girls, in the same way that you figured out the uh, the rule for the number of hexagons, we can figure out the rule for the number of sticks as well, right? Now remember, we already established what the common difference is. So for the number of sticks, it's gonna be that common difference, 8, times the diagram number, which is given as n, plus some value c, right? So this would give us S, which is the number of sticks. So we're gonna substitute values from the table to figure out what C is, and then we're gonna test that rule to see if it holds true for the other values of S. All right? So using the first one, when the diagram number is 1, that means n is 1. So it'll be 8 times 1 plus some value C is equal to this case 15 because in the first diagram, the number of sticks is 15. So 8 times 1 plus c is equal to 15. And then we rearrange this equation to solve for c. So 8 times 1 is 8 plus c is 15. So c would be equal to 15 take away 8, which is 7. So my rule, therefore, is supposed to be 8 times the diagram number plus 7 to give me number of sticks. So let us test the rule to make sure to see if it works, right? So it says to get the number of sticks, you say 8 times the diagram number. So 8 times 2 in this case. So 8 twos are 16 plus 7. 16 plus 7 is 23. So it works out for that one. It's times, when the diagram number is 3 now, times 3 is 24, and 24 plus 7 is 31. It works there. Then we have part 4, when the diagram number is 4, so that would be 8 times 4 plus 7. Well, 8 fours are 32, and 32 plus 7 is 39. And finally, just to be sure, just to be completely sure, 8 times 5 is 40, and 40 plus 7 is 47. So I know that my my number of sticks can be found by doing 8 times the diagram number plus 7, right? So Isabel, I'm asking you again, what about if the diagram number is 10? How many how many sticks would you have? The diagram number is 10.
87 sticks.
87, right? Because 8 times 10 plus 7 will give you 87. Safi, what about if the diagram number is 8? How many sticks would you have? The rule is 8n plus 7. So my question is if n, the diagram number is 8, how many sticks will you have?
Okay, yeah, I was now about to make sure that n is the diagram number.
Yes, n is the diagram number.
And you said the diagram number was 8? You, Miss?
Yeah, the diagram number is 8, love.
Okay. I got 71.
Correct. So 8 times 8 is 64, and 64 plus 7 is 71. All right. So now we've established the rule for the number of sticks. Now to find out the rule for perimeter. Well, we see that the common difference for the perimeter is 4. All right. So let's assume that's a linear relationship, it will mean 4 times the diagram number n plus some value c will give me 12. Sorry, will give me p, the parameter, right? So we're going to substitute values from the table to work out what c is to get the rule. So taking 1, it's always easy to just use 1. So 4 times 1 when n is 1 plus c is equal to 12 because the parameter is 12 when the diagram number n is 1. So that means 4 plus c is equal to 12. So c is 12 take away 4, which makes c equal 8. All right. So the rule for the parameter should be 4n plus 8 gives me the parameter. Let's put it to the test. Well, 4 times 1 plus 8 is 12. But it works for the first one. 4 times 2 plus 8 is 16. It works for the second one. 4 times 2 plus 8. 4 twos, oh, sorry, 3. Sorry, this is the third diagram. 4 times 3. So 4 threes are 12 plus 8 is 20. When the diagram number is 4, that's 4 times 4, which is 16. 16 plus 8 is 24. And then finally, when the diagram number is 5, 4 times 5 plus 8 is 28. So my rule is sound. So that means that the rule to determine the parameter is 4n plus 8. Janaya, are you still there, love?
Yes, miss.
What about the parameter when the diagram number n is 20? What would it be?
88.
Correct. It'll be 88, right? Um, Athena, what about the diagram? Sorry, what about the parameter when the diagram number is 10? When n is 10, what would be the parameter?
48.
Correct. All right. Nia, are you still there?
Yes, yes.
Just checking because I know you like to sleep.
Yes, I'm awake.
All right, good. So once you get the hang of it, and I know it's just taken very long, but that's because I'm literally going through every single step. I'm trying to outline the thought process behind it. When you're working it out for yourself, it's going to be faster, right? But I just want to show you all the thinking behind it because each question will be different, but the strategy, the way you approach the question is the same. Most of them are linear relationships, right? Sometimes you could have a quadratic, meaning that you could have x squared, right? So you could have like diagram number could be 1 and then the number like the parameter for instance or the area could be 1 as well, and then when the diagram number is 2, parameter could have been 4, and then when it's 3 the parameter could have been 9, and what's happening there is that you're squaring, right? You're squaring the diagram number. So it's all about looking for those patterns, and it does get easier with time and experience. Right. So we need to figure out in part 2 what is the diagram number when the number of hexagons is 47 and the number of sticks is 191. Now, it doesn't matter which one of the equations we use. We could use any one of these to figure out the diagram number. So I'm just going to use the hexagons rule. The hexagons rule is 2n plus 1, right? So in this case, I would say that, well, when the hexagons is equal to 47, 2n plus, when the number of hexagons, sorry, is equal to 47, it means 2 times whatever the diagram number is, plus 1 will give me 47. So I write that equation, right? So I say 2n plus 1 is equal to 47. I'm trying to solve for n, right? Because we need to figure out the diagram number. So that would mean that 2n is equal to 47 take away 1, which is 46. And therefore, n is 46 divided by 2, which is 23. So in the 23rd diagram, when n is 23, the number of hexagons is 47. And I could also figure out what the parameter is because I know the relationship to figure out the parameter or the rule is 4 times n plus 8. So 4 times the diagram number plus 8. So this would be 4 times 23 plus 8. So 23 times 4 is 92 plus 8 is 100. So the parameter of the shape when the diagram number is 23 or in the 23rd diagram is 100. There you go. So filling out the table, you got 2, 4, 7 marks. Wow. 7 marks for the table. Skylar says that she can make one of these figures with a parameter of exactly 1005. Explain why she is incorrect. Skylar says, I want you all to try to figure that out. Skylar says that she can make one of these figures with a parameter of exactly 1005. Explain why she's correct. Why she's incorrect, sorry. Any clue why Skylar would be incorrect, guys? Take a minute. Look at the parameter, values
Is
of the
it
parameter. Tell me.
is it because we're adding 4?
Yes, it has something to do with that. But if you add 4 to 1001, wouldn't you get 1005? Ari?
Yes.
It does have something to do with 4, but it's not.
Yes.
What is it?
I think she could possibly be incorrect because it cannot be what is this word? It
A
not
multiple. Yes.
it not divided by 4 without remainder.
Remainder. Yeah. So Ari, why I told you it has to do with something to do with 4 is that it is that 4 is a factor of the parameter of any value of the parameter, or in easier terms, the parameter is always a multiple of 4, right? Which means that 4 can go into it. When you multiply something, you get when you multiply something by 4, you get the parameter, right? So repeated addition of 4 is the same as multiplying by 4, which means that the parameter is a multiple of 4. And since 1005 is not a multiple of 4, that's why Skylar is incorrect. Ari, does that make sense?
Yeah.
Yeah. So the parameter has to be a multiple of 4, and 1005, sorry, is not a multiple of 4. And that's the answer, right? So I mean, you could write some more, like you could literally say 1005 is not uh divisible by 4. There are many different ways you could express it. You could say 4 has to be a factor and 4 is not a factor of 1005. That's one explanation. Another explanation could be this. The parameter has to be a multiple of 4 and 1005 is not a multiple of 4. Or you could say 1005 has to be able to divide exactly by 4 and it can't. Therefore, it's not, therefore she's incorrect. Any variation of that will give you your 1 mark, right? So guys, this question, the um the investigation question is worth 10 marks, right? So it's a heavily weighted question. You want to don't leave it out completely. Like if you're kind of stuck at some point, it's fine. Leaving out a 2 marks here or there, or leaving out a 1 mark here or there is fine. But try to do the majority of the question because as you see, it's a It's a long thing, right? It's 10 marks. But don't get bogged down and overly delayed for a 1 mark question. That would make no sense. Right. So, what at this point, um, actually, let's do this one together, right? Take a minute, look at the diagram, right? And tell me if you're seeing a pattern. And then we're gonna complete this diagram to represent shape 4. So I'm gonna pause it, take a few minutes to figure it out.
Yeah.
But I understand what you mean. You're saying that you're adding a column, like 2 columns down the side like that. And then what about that last row? You see that row there?
Oh, yeah.
They still have that row. Then you're adding basically one more of these, one more column of black ones.
Yeah.
Yeah. Okay. Let's see. Let's try to figure it out. Let's see. So the original in terms of the black counters, we've added 1, 2, 3, 4, 5 here. We added 5 here. And then here we added 1, 2, 3, 4, 5, 6, 7. So then how many would we expect to add in terms of the black one in shape 4? Piano.
9.
Yeah, so we're looking to add 9. And then with the white ones, let's see, added 1, 2, 3, 4, 5, 6, 7, 8, 9. So we added 9 white ones in shape 2. And then in shape 3, we added 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Mm-hmm. So then how much we, yeah?
17.
How much? 17?
Yeah.
Okay. Well, let's see, girlfriend. Let's see if you're right. So we need 9 black ones. 1, 2, 3, 4, 5, 6, 7, 8. Well, if we put one here, um, and one here, that's 2, 3, 4, 5, 6, 7. I think my diagram looking weird. Where should the others go? Where should the others go? Mine looking real weird. Let me try it again. Y'all could draw it too in your book, and you can send me a picture on WhatsApp and help me figure it out. I just know that we need to add 9. I just don't know how to add it. Let's see. Um, hmm.
Maybe you could add just like another layer, I guess, of triangle, of circles on top of the current black triangle. It should make 9.
Like, like where? I wonder, can you annotate? Let me see. Let me see if I could allow you to annotate. With your, are you using like a laptop or are you using your phone?
On laptop, yeah, I could draw like one
Yeah,
here,
draw it and see. Yeah.
here,
Mhm.
and here, here on top.
Oh, yeah. Is that 9?
Yeah, I think so.
Yeah, potentially. Well, you know what? Also, I could probably add the ones around, because I know it's just one column coming down, right? On both sides. and then 1 at the bottom. So
Yeah.
there'll be 1, 2, 3, 4, like this.
Yeah.
Yeah. Yeah. Oh gosh, my drawing looking so crap oh foot. So here, like this, right? Yeah, I think you might be correct actually, Kiana. Let's see. So you're saying put 1 up here. So that would be 1, 2, 3, 4, 5, 6. Yay, you're right. Beautiful. Excellent.
Miss, it looks like a house.
It does. It does. But yeah, thank you, Kiana.
No problem.
There we go. Right. So how many we added? How much did you say? 17? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And you were right about that too. Good. So now let's look at the table. Now it's 2 marks, huh? Ay, ay, ay. I find this one was kind of tricky, honestly. Well, let's see. Right. So in this one, guys, they actually gave us the rule. See? So the number of white counters is found, you're saying 1 plus 1 multiplied by 2 times 1 plus 1. That's 6. Then to get the number of white counters when the shape number is 2, it'll be 2 plus 1. So the shape number plus 1, and then 2 times the shape number plus 1. So this would be 2 plus 1, which is 3. Remember BODMAS, right? BODMAS is where you work out brackets first. So this would be 2 times, and brackets means multiplication. So this will be 2 times 1 is 2 plus 1 is 3. So 2 times 3 is 6. Let me just make this a little bigger. And then we have 2 plus 1, which is 3, times 2 times 2 is 4, plus 1 is 5. So 3 times 5 is 15. And then 3 plus 1 is 4. 4 times 2 times 3 is 6, plus 1 is 7, which is 28, right? So for 45, you would have expected, well, the shape number 4 plus 1 times shape number again 4 times 1, 2, 3, 4 plus 1. Not 2, not 4 here, sorry. Not the shape number. There should have been 2. Sorry. Made a mistake. It's 2 times the shape number. So yeah. I don't know why my screen is like glitching like this. Yeah, so this would be 4 plus 1, which is 5. 2 times 4 is 8, plus 1 is 9. So 5 times 9 is 45. So there we go. Right? And then the number of black counters is found by the shape number plus 1 all to be squared. So it'll be 4 plus 1, which is 5, all to be squared, which is 25. Because 4 plus 1 is 5, and 5 squared is 25. And then to get the total number of counters, what is it increasing by? Let's see. Is there a common difference? 24 take away 10 is 14. 24 take away, 44 take away 24 is 20. What is the common difference? Oh, they gave it to us. It's actually a quadratic, right? So it's 3 times the shape number squared plus 5 times the shape number plus 2. So that would be, so this, to get the number, the total number of counters, you would have to do 3 times the shape number, in this case it's 4. So 3 times 4 squared plus 5 times 4 plus 2. So that would be 4 squared is 16, so 3 times 16, which is 48, plus 5 times 4 is 20, plus 2. So 48 plus 2 plus 20 is 70. So the total number of counters is 70. All right. And now we need to figure out um the the shape number when the number of black counters is 144. Easiest way to do it would be to use this rule. The shape number plus 1 all to be squared is equal to 144. So let's fill out the rule first of all. Always easy to fill out the rule first because that gives you the equation, right? So for the white counters, it was n plus 1, right? Multiply by 2 times n plus 1. That's what the rule is. N plus 1, as you could see, like when the shape number was 2, it was 2 plus 1, that's n plus 1. Multiply by 2 times the shape number again, which is 2 plus 1. Right? So when the shape number was 3, it was 3 plus 1, that's n plus 1. Multiply by 2 times 3 plus 1, which is 2n plus 1. And then for the number of black counters, it's the shape number n plus 1 all to be squared. All right? So for this one, to figure out the shape number when the number of counters is black, we use the equation, right? We use the n because we're trying to figure out n. So n plus 1 is n plus 1 squared. N plus 1 squared is equal to 144. So Nia, to get rid of this square, you have to take the square root, right? Of both sides because the opposite of squaring is taking the square root. So n plus 1 is equal to the square root of 144. So therefore, n plus 1 is equal to 12. So if n plus 1 is equal to 12, that means n is 11. All right. So to get what the number of white counters would be, it'll be n, let's substitute the values there. It's 11 plus 1, that's 12. Multiply by 2 times 11 plus 1, which would be, well, 11 plus 1 is 12. 2 times 11 is 22 plus 1, which is 23, and 23 times 12 is 276. And there we have it. All right. The expression for the total number of counters P is equal to W plus B. Guys, actually, we're gonna stop there for today. I feel like you all have had enough of this. Um, I'm going to upload this to our Google Classroom. There are still, I think, 2 more questions in there, right? And I want you all to try it. This one, though, let me just shade this in. Yeah, I want you all to try it. See, give it a shot. Use the same